Hello, we're back again to continue the measurement of preliminary item. And we stopped as item 9 before I deviated into taking us on how to measure preliminary items. And if you have missed out on the first 9 items, you can catch up by visiting my page at www.youtube.com/Pontisovian Made Easy _2014. There you're going to get the video concerning site management and administration, plant and equipment, fueling, site accommodation and consultant, telephone, office furniture, computers, and welfare, all those are barrier, signboard. And we are going to be dealing with 10 and 11, which is temporal work, temporary fencing and access road. Then possibly I am going to talk on electricity, water, watching and lighting, because to best explain this aspect and possibly touch on plant and equipment, I told us when I took us on plant and equipment that there are some critical informations you need to better put you in a position to measure those items appropriately. And I did said for the plant and equipment, you need a site installation drawing, a bill of quantities to measure this item appropriately. And in this video, I'm going to use a sketch, a typical site installation drawing to better explain to us some of the things that made me say that information is of vital. Then it will now explain the temporal works, temporal fencing and access road, and watching and lighting. So I'll quickly pick the less cumbersome drawing to first give us a prep before we go into the difficult one. As you can see, this is a site arrangement. The ones in the pink colors are the buildings that this contractor needed to build. And as soon as the call for tender is made, it is very important that the contractor lay hands on the site layout, indicating the location of the new building. One, what that drawing will help him do is for him to know where he will site some of his plants and how he's going to run his cable, run his water and all of that to make the site a coherent unit. As you can see in this drawing, the buildings that are above one floor, there are cranes, and you can see this crane is going to be positioned here, and it has a boom of 440 meters, meaning that the circumference is enough to cover this building. And you can see there's an individual generator for this crane. And this crane has a rail, and the rail is not going to sit on the bare ground. The rail is going to be on a reinforced concrete beam. That is where you have the tracks, and the tracks will be laid on that reinforced concrete beam. And that reinforced concrete beam is an item of cost. So, and this generator is going to rest on some pedestal, concrete pedestal, block pedestal, so that it can be elevated slightly from the ground. Those items are items of cost. As you can see, because the distance between this building and this building is far off, uh, one gen cannot service the two of this crane. Uh, another generator was provided for this crane. But in this case, the crane is going to be stationed in one place. But in this case, the crane is going to be traveling. It's going to be moving from this end to this end. The length of the track is 24 meters. So automatically, you know that you're going to cast slightly above 24-meter the beam that is going to rest on it. Then, of course, already it is indicated the width of the beam is 1.2. The depth will be determined by the nature of the soil that this is going to rest on. If the soil is very hard, sometimes the thickness of the beam will be maybe 40, 50, 500 millimeter thick. But if it is in a swampy area, it can go as high as 801 meter. So then you see this other crane as well is going to be traveling 42 meters. And the span, because they wanted this crane to cover this building and cover part of this building, why this other crane that is going to station will cover the larger portion of this structure, 11 and 12, 11 and 12. Then this one will take the part. That is where you see the crane. This crane is intercepting at this position. So you're going to have a beam of 42. You're going to have a singular generator for it. Then for this other one too, is going to run 48 meters. 48 meters, and the same beam you're going to cast for all. So all these items, you have to take cognizant of it when you are pricing your temporal works. These are all within the range of temporal works. Then coming to the the office area, as you can see, already indication showing how the office is going to be arranged. In this case, porter cabins are deployed, and you can see the porter cabin for a cost controller, a small container for the security post, the timekeeper. You have the supervisor. You have the engineer and the QS in one porter cabin. You have the project manager and his secretary in one porter cabin. You have the cost control and admin. You have the quality, safety. You have the timekeeper. You have the design. You have the purchasing and logistic. You have the tea room and the radio room. Then, so with this arrangement, you can pick out how many porter cabin, office cabins you need. And this has to do with plant and accommodations. So you can now know how many cabins you needed to provide to set up this arrangement. Then you have the safety tank, this is safety tank, the water tank. This water tank, this is another tank. Then creating a church space for prayers. You have the clinic, you have another office here, you have a safety tank here. You have the changing room where the workers in the morning change to their working clothes, and the toilet closer to it. Then you have the canteen. All these are within temporal works. You have the carpentry workshop. This carpentry workshop, you're going to have a concrete slab all over. Then you have either wooden structure erected above the concrete slab, or a steel structure and a roof over it with machineries under. And usually, in this case, you know the kind of machine you want to bring it, planing machine, so cutting machine, reducing machines, and all of that. So that forms the type of machine, the small machineries you needed to bring as part, it falls within your plant and equipment. You have the steel storage stack. This steel storage stack, some concrete works needed to be done. You have some bays where the steel will be elevated above the ground, then like a rack. Then you have some partition dividing it into the sizes of bars. So all here you do some temporary work. You have the steel workshop where you're going to have the bending machine, you have the cutting machines and all of that. So the cutting machine, the bending machine, then the steel bending machine, all you know the machines that will come into this place, then you make appropriate provision for them in the plant and equipment. Then here already is indicated you're going to have two batching plant. This is one batching plant, this is another batching plant. The capacity of the batching plant will be determined by the volume of concrete that you're going to cast on that project. If you have the bill and the bill says you have, say, 100,000 cubic meter of concrete, and the project is for the period of 1 month, for the period of 1 year. And you know the output of this batching plant is 22 cubic meter per hour. And you needed to cast, say, 2,000 cubic meter for 1 day. So you needed more than one batching plant. So that is why here is provided. And if it will interest you, this plan in review is a cement factory that I was part of. I was part of the team that went and built it. So you can see all the arrangement up till you have the plant workshop, and the plant workshop has an office. It has two store. These are containers, empty containers of 40 feet or 20 feet, depending on the kind of materials that they need to stack there. You have a car washing machine, a car washing area. Definitely this washing area is concrete. There's going to be concrete slab. And as indicated here, you can see there's a ramp in telling you that it is a washing area that the water needed to be retained in the area, then either channel to a drain where the water goes. So the car goes into this place, drives into the ramp, like a pool. After you finish washing, it goes out. Then you have the aggregate depot, the sand and the cement. Then with this batching plant now far away, it is self-erected, what do you call it? Self-refilled batching plant where the payloader comes to this place, uh, fetch the sand, fetch the granite, brings it close here. There are shovels, there are automated shovels that revolves around and moves the. It's like it's a smaller shovels that scoop the granite, take it and drop it into the drop. And after it gets to whatever the way is, it will stop. So as you can see, this one is giving us some explanation how the site layout is, and you can now extract the kind of machine, the kind of equipment that you needed for the trucks and either excavator. You know that I did said what determines how many you will provide for is the volume of earth you needed to excavate. So that will be determined by the number of months you have earmarked that you will excavate the whole of the volume in the bill. So that will give you, for the trucks and the excavator, probably as well compactor. But this area will give you the batching plant. And look at, we have two generator here, two air compressors, compressor here. You have a borehole, you have a water booster, you have a water tank. So the water booster boosts the water that you have drawn from, you have pumped from the borehole into this tank. It boosts it to the various location that it is needed. So I will take us now and further explain to us with another drawing, comprehensive. The other drawing has the where you can measure your watching and lighting. You can measure this length of cables that you needed to electrify this area, because it is showing you even the kind of panels that you provide at each junction for the workers to tap lights wherever they needed it. So I take you now to this. As you can see, uh, let me, you can see this size of armored cable, 5x6 cable, 5x6. This is 4x16. This is a 100 kVA generator. This is 20,000 liter water tank. This is diesel tank, 12,000 liter diesel tank. So this tells you how many you needed to provide a 20,000 liter water tank. This you provide a 12,000 liter diesel tank. This you are going to provide a CO2, a dry powder for in case of fire. Here now you have, here is a distribution panel. You can see the cable 5 by, then you have a lighting max. You can see how they light up the site. You see this color of the color of cable is going round, and you have one mat here. You come to this area, you have another lighting max here. You go to this other area, you have another lighting max. So for you now to determine the length of cable and the cost of cable you are going to uh, provide light here, you have to measure all, because already this site installation drawing has shown you how the routes, how the cables are going to run. Then you take them by their sizes and put your price against it. Here you have a single generator, a distribution box, and the cable is a 4x35 flex. You have you provide a sand bucket, a CO2, a dry powder, and a distribution panel. You come to the offices on this project. You have the QS, you have the tea room, you have the, look at them. You can see cost control, admin, quality and safety and environment, engineers, project manager, the cost control office, the supervisors, the consultant, design and copy. So you can, with this, if you have this kind of information, that is why some organization call their estimating department studies, because it's a complete study of the project for you to come out with a very reasonable and realistic bill that, you know, once you go into the project, you will not fall back to start crying that there are things you never take into consideration. You can imagine if this is not drawn to ascertain all of the things that needed to be provided for this project, and you just sit down and off heart you are just assuming without having something that will guide you. Then wherever you needed to assume, in addition to what has been done, you assume. You assume and make the bill a realistic bill. You know, it's definitely going to fail. So as you can see, for this project, you have how many crane? You have a batching plant, just one batching plant. You have one crane that will be traversing from this location to this location, and the boom is 65-meter boom. So the crane is going to cover 65-meter boom. So by the time it goes round, because it cannot cover all, you have another crane here, and it's going to traverse 34 meters in length, and you have, it is 65-meter boom. So it can cover the whole of the 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 building, the proposed building. And if you go inside of, you see the cable 4x16, 4x35 armored cable. You have a compressor here. You have a water tank, 20,000 liters. You have a booster pump that boosts 10,000 meter cube, 10 meter cube in 1 hour. The compressor is used for jackhammer. It's used for vibrating concrete. It's used for vibrating concrete, and it's multi-purpose. The mechanics as well can use it to dust up their filters for heavy equipment and all. So it is central. Like compressors of this size, once you have one of them on site, what you need to do is extend your hose to wherever you want the air, and your job is as good as done. You come to this area, you see the plant workshop, the steel storage, you have the steel workshop, you have the carpentry workshop, and the cable that gives them light. All these are panels, sizes of panel. This armored cable brings light to this panel, and it came from the generator. Then another panel, distribution panel, goes like this and drops another panel is here. Then another cable takes from the generator of 4x35 and take the light to the AP160 panel, and AP160 panel. Then you have all of the cable. So you can measure your cable. You can measure how many the distribution panels of different sizes that you needed to provide, where workers can easily tap, connect the extension for work and all of that. Then there are other smaller panel, the I40, that are provided at floor level and it has multiple outlet that you just connect your whatever. Then the access road, you can now see that, you see, look at temporal access road. The temporal access road will run round in this manner, then come out at the gate, which is the gate is somewhere. It's coming out at the gate somewhere. Where? The temporal road is running round, going around this way, going around. It's going around the site. Definitely, it's coming out here where we have the gates. This is the gate, and this is a security post. There's a lighting marks by the gate, and these lighting marks are high with a big halogen that the light illumination can go far. So, and you know the size, you know the capacity and all of that. Then you now, with this drawing, it enables you now to measure all your temporal works. Then I take us to the bill, and you see I detailed it as order installation. And so in this aspect, what you needed to calculate now is you have drawings for each of the each of the temporal works that have been marked that will be on site. Like for the steel workshop, I have a timber structure. I have a steel columns that will receive the timber structure and the roof covering, the slab under. You have the roof sheet long span. You have the roof sheet long span is appearing 2 areas. So this will go. So this is the cost for the steel workshop. The canteen, this we are going to measure. We are going to measure each of those structures according to the assumed design that is going to be. You measure, like for the canteen, it's going to cost 2 million dry cost, 2 million direct cost to build. The changing room and the shower. The changing room and the shower. This is roof. This is roof long span. The changing room and the shower is going to cost 3 million. The gatehouse, 2 meter by 2 meter by 2.6 height, is going to cost 804,000, assume. Then the crane rails, those rails, I said, the concrete that we're going to cast to place the rails on them, is going to cost 1.7 million. The generator, office cabin base, you have to put some pedestals for the cabins to rest on it. The water tank, booster, and all is going to cost 3.2 million. The carpentry workshop, 30 meter by 15 meter, is going to cost 4 million. The safety tank for all the foul water, wastewater, is going to cost 800. The access road. Now, the access road is going to determine the total square meter, and the total square meter of the road is 6,000 square meter. Clearing of the topsoil is going to be at 182,000, 182 naira per square meter. Cutting away of those at 900 cubic at this. Then spreading of stone base is going to be at this. It's going to cost 9 million. Then temporal fencing, 20 meter length. After determining the 20, then the excavation and all is going to cost. You're going to, okay, the excavation, because it is a chain link fence. A chain link fence, you're going to do, you have excavation for where the poles at 3 meters will be mounted. Then the concrete to cast the 3 meter in place. Then you have a 500 numbers of galvanized pole, 2.5 meter height. 500 will go into the ground, 2 meter will be remaining to receive the chain link fence. You have a 61 million for that fence. Then sampling and testing. Normally where it's expected of us at intervals during casting of concrete to cast some cube and crush them at different days, 7 days, 21 days, and then the next 30 days to determine the strength. That is an item of cost. Let's say you don't have a crusher on site, you need to take it outside for a paid organization to crush it for you. You can determine that. Let's say you have the sizes of the number of cube. If you're going to cast for each 10,000, you're going to cast 30. So you divide it, you have about 30,000. That you're going to have 303 pieces to be crushed for a 10,000 cubic meter that you are going to cast on that project. This is an assumption I'm just giving because we don't have a project in review here. Say you want to cast the project total cubic meter of the concrete, and on that project is 10,000, and it's expected that you cast 30 per each pour. You know how many times you're going to pour. Say, you know how many times you're pouring, how many cubic meter you're pouring every day, and how many cubes you needed to do. But sometimes it is expected for every 30 cubic meter you cast, you make a cube test. So if that is the case on the project that you are, definitely now you have to divide that total cubic by 30, and you come up with how many of the cube that you are going to be crushing. Then you put a cost to it, because the cost of the cube maybe per each crush is 10,000. You multiply it by the number of cube that you're going to cast throughout the duration of the project by 10,000, you have the number. Then the cost of the concrete itself, that you're going to use to cast those, this thing is not, it's item of cost. You're going to pay money. It is money you bought the cement and the granite. So I now multiply the 333 by the size of the cube test, which is 20 by 20 by 20, and it gives me almost 3 cubic meter. Multiply by the unit rate for it gives me 137. So you can see for this assumed project, order installation is almost a 90 million. Order installation is almost a 90 million. And some of the rates, we'll discuss rate build up on another video, but just to give us a tip on how some of these rates you are seeing came about, like the concrete. I have these are my basic just like I did said on when I was taking us on how to measure, where I said you can link everything, and once you update your unit rates, it goes to your basic rate, it goes to your rate build up. Then you link that to your bill of quantity. Once you update this area, which are schedule of basic rates, these are rates for a project outside the shore of this country. These unit rates are in CFA, so let us not look at them and start applying them. They are a project that I was part of outside the shore of this country. So be guided. Don't use this rate for anything. They are just for purposes of illustration. Then here I have my labor rate, excavation per cubic meter, my backfilling, my plastering, and all of that. Cost of plastering per square meter, cost of plastering, sealing, and all of that. Then these are my unit rates. These are my unit rate for different grades of concrete. These are my unit rate for different grades of concrete. I have the grade of concrete. These are 150 kg concrete, which is mostly blinding concrete. I have a 250 kg concrete, and the difference in all of this thing is the cement. If you can see the granite 3/4 and a half inch, they are the same. The sand is 0.4 0.40 0.0409, while the granite, the water is 150 liters into it. After, these are the unit rates coming from this schedule of basic rates. These are the unit rate for cement per ton. This is cost of granite, 15,333 per ton, and this is the cost of water. After applying that, you have this as your dry cost. Normally the 5%, we are all taught in school, you have to apply, you make provision for shrinkage, you make provision for what do you call it, when you are transporting it, some of the concrete will fall over and all. But basically, big construction company, they keep data from their various projects, and these data help them to determine what is the level of waste in time of concrete, in terms of plastering, masonry. Then they can just apply a rounded figure. So there's no point putting shrinkage waste, putting transporting waste, putting of whatever, all of the waste. So in this case, say it is a 5% waste across all boards for all of this item. Then you apply, you multiply I take out this. It's supposed to be times 1.05. 1.05. Then you have your labor cost of 8,000 per cubic meter. So if you add this to this is your dry cost. So this is your direct cost without profit. So in this case now, once you link it to the bill, you link this to the bill where you have the concrete, then the coefficient that was determined here, this coefficient that was determined here, placed on at the top, and you're using a dollar sign to pick this coefficient multiplied by the dry cost gives you the selling. Then that is when the direct cost, I'm talking when this I'm explaining is when you are pricing the direct cost. I'm only just linking because I'm discussing concrete. That is why I am linking this now. So when you pricing direct cost, this portion where I've clicked my cursor is where I will link all my direct works cost into. Once I link it into this place, probably something will shake here. Then this one is what you're going to link to the bill that will now multiply by the dry cost to give you what the selling will be. Then by the time you finish this direct cost with the indirect cost, the direct cost and the indirect cost, and this will be your selling. This will be the figure that will appear in your letter of uh, your letter of offer, that this is what I'm offering to do this job for. So, so having said this aspect now, I will now sum up all these ones, all of them. I take out the access road since here we have the access road and the fencing as they are together. I just come to this place now. I pick the access road. I pick the fencing. Then I sample and testing. I go back. I pick. Oh, sorry. It's not supposed to come here directly. Sorry for that. It's supposed to first come to the summary. It's supposed to come here first. It's supposed to come here. We have the access road. Then I have my temporal works, which is the summation of this, 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 this. I go this way. Some to be more faster for me. Please. Injury workshop, safety tank, and I think that is all. Then I get to this area, I put a sample and testing. Sample and testing. So now I link to my sheets, the the selling cost, Emperor Works, then access road and fencing. A link to this, then sample and testing. Sample and testing, I link, sorry, I link to this. So like the electrical, the water, I guess, and the watching and lighting, I guess my explanation has account for this. But if you want me to run over it again, the watching and lighting that I need now, for me to get my watching and lighting, is for me to go here. I go here, this cable running all through for the lighting marks and the locations, because usually on the cranes, at the top level of the cranes, some halogens are placed there. If the cable is going to run along the crane and either go to the halogen or on top of the crane, so you measure the cable that is serving all of the lighting marks here with other lighting and the other lighting here. You measure them and you place them there. Then the water supply as well, the pipes location where the pipe is running, going to the bedroom, the toilet, and even serving the batching plant, the washing area, and all. You just value what the cost is and you place it there. Thank you for watching. Watch out for the next video. I still remain Canis. Thank you.